Okay, let us continue with our process of finding the zeros of polynomials of degrees higher than 2. So we discussed 3 theorems, and now we will see how to apply those 3 theorems: the rational zeros theorem, the remainder theorem, and the factor theorem. So the process or general process of finding the zeros of a polynomial p of x of degree n. What is the process? The first thing is you have to find one zero, and let's say call it C1 here for here. So what is the step for finding that zero? You will list all the divisors or factors of the constant term, which we denote by P. These are the possible values for P. And then we will list all the factors of the lead coefficient, and these are the possible values for Q. And then we will list all the possible values of P over Q. Okay. Now these are basically the possible rational zeros of our P of x. So it could be there is only one rational zero hiding in that list, or there could be more than one rational zeros. So we list all the possible values of P over Q, and then we one by one we plug them into the polynomial P of x and try to see if any one of those gives us a zero as a. So according to the remainder theorem, then that would be the zero remainder of the process of dividing the polynomial by the corresponding linear factor x minus c1. So that's what we do basically. Now we divide our polynomial by x minus c1, and according to the division algorithm that again in the 3.5 AA I explained. So according to that, we can then write our P of x as Q of x times x minus c, or x minus c 1 times Q of x. It doesn't matter which one you put first. Sometimes I would write it like this, which is fine. Okay. And the degree of this Q of x will be 1 less than the degree of the polynomial. Okay. Now, if Q of x is a quadratic polynomial, you can find the zeros by factoring or by using the quadratic formula. But if it is not, then you have to keep moving the process on, keep going on. Okay. And once you have found all the zeros, then you can put the polynomial P of x in factored form. Okay. So these are some kind of tips for you to check if these are helpful. So the first one is saying if P of x is all positive terms, you do not need to try the positive numbers in P of x. So what it is saying is if your polynomial looks like, let's say it's a third degree polynomial, and it is like x cubed plus 3x squared minus 5x plus 7. So if you are getting, like, let's say one of your P over Q values is 1, 2. Well, 2 is not going to be a 1, because if I put 7 here, then the possible zeros of 7. So in this case, we will get plus minus 1, plus minus 7 are values of P, actually the possible values of P over Q. So we do not need to plug in 1. We do not need to find P of 1, because you can see everything is positive. So if everything is positive, if I plug in a positive number for x, I'm just going to get a positive number. It's nothing to cancel out to make it a 0. So that's what is being said. So that saves you time if you can see those things. Also, there is a process called synthetic division. So instead of the long division, if you want to do synthetic division, you may, if you already know the process, if you already know how to do synthetic division, because in here we don't teach synthetic division in class. So here, let's look at the first polynomial. Now this polynomial is something we can factor without going through the process of that I just explained. But if you want to go through that, you may. But if usually if you can, if there is a method like by factoring, by you can factor, or for example for a quadratic polynomial you can factor, or you can use quadratic formula. You do not have to go through this whole the process of, you know, this long process of finding the, using the remainder theorem and all that. So this one I can factor easily, because this is what we say is the quadratic form. This is not a quadratic, but this is a what we say is quadratic form. So we can see that by doing a substitution. So I say let u is equal to x squared, then u squared will be x to the 4, and your polynomial becomes u squared plus 10u plus 25, which can be factored as u plus 5 times u plus 5. Or now if I replace the u by its value, which is x squared, so I get x squared plus 5 times x squared plus 5. So you see this is a repeating, it has some repeating roots. So now how can I find the zeros? Because we want to we can write our polynomial in this form, in factored form, yes, but it is not the fully factored form, because we have to, in order to have the fully factored form, we need each factor to be a linear factor. So if you can directly see it, you may write it directly from here, what the linear factors are. But if there is any confusion, or just to avoid any mistake, you can come here, you can find the zero. So you will set the factors equal to 0. So each, basically two factors, so we will set each of them equal to 0. But since both are same, we can just set one time the factor equal to 0, and we end up getting x is equal to plus minus square root of 5i as factor. So I will have, when I put it in the factored form, this is what I will get: x minus square root of 5i times x minus square root of 5i times x plus square root of 5i times. So you can see that these are actually whole square. So we have zeros square root of 5i, and then we have the zeros negative square root of 5i, and both are of multiplicity 2. Next example I did for you. So now this is something that we cannot factor using our usual techniques. So we will try to do it with the technique that was explained in this section. So first we write down what is our constant term. So constant term is 10. And what is the lead coefficient? It's 1 over here. So now P are, the possible values for P are, well, you have to figure out what are the divisors of 10, what divides 10. Now remember, 1 divides every number. So when you are looking for factors of a number, 1 is always going to be there. So for 10, the factors are 1, 2, 3 doesn't go in 10, 4 doesn't go in 10, 5 goes in 10, 5, then 6, 7, 8, 9 don't go, and then 10 goes. These are the factors of 10. But when we write them here, we have to write them as plus minus, because if 2 divides 10, negative 2 divides 10. 5 divides 10, negative 5 divides 10, and so on. So I have, and the factors of P are, or the possible values of P are plus minus 1, plus minus 2, plus minus 5, and plus minus 10. And now factors of Q are only plus minus 1. Now to find the factors of P over Q, remember we will divide each possible value of P by possible value of Q. So we will get plus minus 1 over plus minus 1, which gives us back plus minus 1, which is what I have here. Then the next value of P is plus minus 2. So we divide it by plus minus 1. So we get plus minus 2, and so on. So now I will try one by one. By chance, now look here that I tried 1, the first factor that I thought of, and that gave me 0. Okay. So I found P of 1, and I found that plugging in 1 into the polynomial gives me a sum of 0. So what does that mean? It means 1 is a factor, or 1 is a 0 of the polynomial, which will mean that x minus 1 is a factor of the polynomial. Okay. So now we will divide the polynomial by x minus 1. So here is my division, and here is my remainder. Now you just have to check that you must get, if you found that P of 1 is 0, then when you divide by x minus 1, the remainder must be 0. If remainder is coming something else, then you have made a mistake in your division, or you made a mistake in finding the P of 1. So be careful about those things. So once you find that you are getting a 0 as a remainder with the division, a long division or synthetic division, then you can write your P of x as the divisor times the quotient, or quotient times the divisor, your choice, it doesn't matter. But now let's look at the quadratic factor. In this case, it can be factored easily as x minus 5 times x plus 2. So zeros are 1, 5, and negative 2. I can tell by just looking at P of x, or you can do extra work here, that x minus 1 equal to 0, x minus 5 is equal to 0. So you are finding the zeros. That's why you can write this. And then you get x is equal to 1, x is equal to 5, x is equal to negative 2. And each of them are multiplicity 1, and here is the polynomial written in factored form. Okay.